Hello, and in this session we're going to be talking about counting problems involving addition and multiplication rules. In the first problem, there are 11 major amusement parks and 15 great beaches in New York. If you are planning a trip to visit one of these parks, followed by one of these beaches, how many different trips could you make? In step 1, we choose a park in which there are 11 different possibilities. And then for step 2, we choose a beach in which there are 15 different possibilities. Because of the word and, we use the multiplication rule, so the total number of possibilities is 11 times 15. In problem 2, if you plan to visit either one of these parks or one of these beaches, how many different visits can you make? In step 1a, we choose a park in which there are 11 possible ways, or we could choose a beach in which there are 15 possible ways. Because of the word or, we can use addition. So the total number of possibilities is 11 plus 15, which is 26. In the second problem, a burger is offered with 10 different optional toppings. The restaurant claims that there are more than 1,000 different combinations available. Is this claim justified? In step 1, we decide on the first topping and whether to accept or to reject it. There are two possible ways, since we can either accept it or reject it. And then for step 2, we decide on a second topping in which we can either accept it or reject it. And we continue until the 10th topping, in which we can either accept it or reject it. Because of the word and, we use multiplication rules, and we get 2 to the power 10, which is 1,024, which is bigger than 1,000. So their claim is justified. In problem 3, set A has m elements and set B has n elements. How many one-to-one functions can have with A as a domain and B as a codomain? Assume that n is bigger than m. Assume that the elements of m are a1 to am and the elements of B are b1 to bn. For step 1, in choosing a value for f of a1, there are n possible ways. And then for step 2, for choosing a value f of a2, we can pick there are n minus 1 possible ways, since the function is 1-to-1. And so on. And step n, for f of am, there are n minus n plus 1 possible ways. Because of the word and, the total number of ways is n times n minus 1 times all the way to n minus n plus 1 possible ways.